Hi students, good morning to all. Today we are going to discuss the fourth concept in fifth unit. It's nothing but explanation based learning. So what is meant by this explanation based learning? Before entering into the concept, what are the topics are there in this concept? The first one is introduction and second one extracting general rules from examples and third one improving the efficiency. So inside of this one we have another point called operability. So these are the three most important concepts or exist in the concept of explanation based learning. So first we are going to discuss the first concept, introduction. So introduction of explanation based learning. So what is this explanation based learning? So explanation based learning is a method for extracting general rules from individual observations. That means, so in the artificial intelligence we want to observe what is the environment given for us. That environment we want to observe carefully and we want to extract the general rules from that observation. So whenever you generated general rules or you extracted the general rules or methods from that observation, then that concept will comes under the point of explanation based learning. So explanation based learning is nothing but a method for extracting general rules from individual observations. So from the observations, what are the general rules we are extracting? This method comes under explanation based learning. As an example, consider the problem of differentiating and simplifying algebraic expressions. So the example for explanation based learning is nothing but differentiating and simplifying algebraic expressions. So general algebraic expressions, simplifying the algebraic expressions or differentiating the algebraic expressions, all these concepts comes under explanation based learning. So at a small example, if we differentiate an expression such as x square with respect to x, we have time to x. So this is a problem given to you. What is that? X square with respect to x, we have time to x. So we are deriving this concept now. So what is that? The technique of memorization has long been used in computer science to speed up programs by saving the results of computations. So in the computer environment, why we are using memorization means to speed up the program by saving the results of computations. For saving purpose, what is the computer results is there. To saving purpose and to speed up the program, we are using memorizations in the computer science. Then the basic idea of memo functions is to accumulate a database of input or output pairs. So the basic idea of memo function is to accumulate the database through the input and output pairs. So when the function is called, it first checks the database to see whether it can avoid solving the problem from scratch. So that means, so what is the general point means? So when using the database, so if already functions are executed, those are saved in the databases. Whenever the same type of functions are called, it first checks the database to see whether it can avoid solving the problem from scratch. So already if the answer is solved and answer is there, why should we need to solve the problem again? So that's why once it checks the database, already the problem is there to avoid solving the problem again. So this is the concept of this database concept. So if database is there, the results we can store in the database. once again execution, second time execution, we can avoid that one. So that is the main purpose of these databases. So for maintaining these databases, we require these types of rules. So explanation based learning takes this a good deal further by creating general rules that cover an entire classes of cases. So for storing these database formats, all these things to take is a good deal to create general rules to cover entire classes of cases. So how to solve all these things? We are creating the general rules. With the help of those rules, we covering the entire classes of cases. So in this explanation based learning, nothing is there, Nana. We need to remember a single point. It's nothing but with the help of this learning, we are creating general rules to solve any problem. We creating some rules. So that formation of rules or creating these general rules is nothing but explanation based learning. So in the case of differentiation or memorization, could remember that the derivative of x square with respect to x is 2x. So already we derived this concept, x square with respect to x is 2x, but would leave the agent to calculate the derivative of x square with respect to x from scratch. So we leaving the agent to calculate x square with respect to x from scratches. So in logical terms, this is expressed by the rule. So that solvation of x square with respect to x into 2x, logically how we are solving means this is the logical formula. Arithmetic unknown, u is equal to derivative there x square, here u square comma u is equal to 2u. So variables are changed. There we used x, here we use u, but the same formula. Derivative of x square into with respect to x is equal to 2x. So logical manner we are represented the same concept in this format. So if the knowledge base contains such a rule, then any new case that is an instance of this rule can be solved immediately. So if you found these types of rules, if any new case which is instance of this rule, that means it follows this rule, then that problem is solved immediately. So that's why we want to form the general rules. So to explaining these general rules concept is nothing but explanation based learning. For example, always we also using the same concept in our general life. So to solve any problem, so always frequently if any problem is occurring, what we are doing? So every time the same problem is occurring, so find out a formula or solution for this problem. So once it's, a solution is identified, then other time the same problem is occurred, we are applying the same formula or solution to solve that problem. So that is the concept. So finding that solution or general rules is nothing but the concept of explanation based learning. So that is the first concept, introduction. Then come to the second point, extracting general rules from examples. So here some examples are taken. From that example, we are extracting the general rules. How? So just go through it. The basic idea behind explanation based learning is first what we want to do, construct an explanation of the observation using prior knowledge. So first we want to construct an explanation what you observed from the environment by using your prior knowledge. What is the knowledge you have? Based on that, you want to construct a small explanation based on what you observed from the environment. That is the first point and idea behind this explanation based learning. First, you want to construct an explanation, and then to establish a definition of the classes of cases for which the same explanation structure can be used. So after finding that explanation, then you want to find out to which classes of cases you are going to use this explanation. So first we want to find out or construct the explanation. Then you want to define to which classes of cases, you are going to use this explanation structure. So we want to define that one. That is the second one. Then this definition provides the basis for the rule covering all the cases in the class. So what you are defining here, that one gives the basis of covering all the cases in the class. Whether this rule, so what you defined in the explanation, if that rule covers all the cases in the classes or not. So we want to identify that one. So how we are extracting the rules means, first you want to construct the explanation, then you want to define which classes of cases you are going to use for this explanation. Second one, then based on that definition, it gives whether that rule or that explanation covers all the cases in the class or not. It provides that detail. After if you applied that explanation on that classes, it gives this result. Then the explanation can be a logical proof. What the explanation you have defined, that one we are calling as rules. So rule or formula is nothing but it is a logical proof. But more generally, it can be any reasoning or problem solving process whose steps are well defined. So in the problem solving environment, that logical proofs wants to provide in a well defined steps. So the key is to be able to identify the necessary conditions for those same steps to apply to another cases. So you want to identify the necessary conditions to apply for any other cases. So nothing but finding a formula. Then, so for example, if you take 1 into 0 plus x, so how to solve this expression? Just come to the knowledge base, include the following rules. So these are the following rules. Logical proofs or logical rules are given here to solve this problem. So just remember these rules at all. Then solution. So the solution for solving the problem 1 into 0 plus x. So to solving that one, we are represented in the diagrammatic representation. So first tree structure format. So simplifying that one. So rewrite the concept or simplifying the concepts. The same type of formulas. So what we seen in the previous slide, that formulas are applied here. Simplifying, primitive, arithmetic, the same. So two manners we can apply this concept. So two tree structures are there. Okay. So based on these two tree structures, we are giving the proof. So for the explanation based learning, the explanation based learning method actually constructs two proof trees simultaneously. So for explaining that example, so explanation based learning methods gives two proofs. So two tree structures are given here simultaneously. So what will be happen? Just come to the point. The second proof tree uses a variabilized goal in which the constants from the original goal are replaced by variables. So just come to the second one. In the second one, we are using variabilized concepts. So where we are get this variabilized means in the original goals we used constants. With the constants from the original goals are replaced by variables. So what you are used the constants in the original goals, those constants are replaced here as variables. So that's why in the second proof tree we uses variabilized concept. So the original constants are converted here as variables. So that one here we are called as variabilized. And as the original proof proceeds, the variabilized proof proceeds in step using exactly the same rule applied. So both may use the same rules. So already we discussed saw the rules. Those rules will be used here in the same manner. So once we have the generalized proof tree, we take the leaves. So in the tree, leaf nodes, leaves, and form a general rules for the goal predicate. So with the help of those leaves in the tree, we form a general rule for the goal predicate. So to predicate the goal, we used the leaf nodes to form the general rules. So that is the point. So for this, the procedure is given in 4 different points. So to recap, the basic explanation based learning process works as follows. How it is working. So in 4 points clearly gives how the explanation based process is working. First, given an example. So take an example. Construct a proof that the goal predicate applies to the example using the available background knowledge. So first to take an example, anything that example. So for that example, construct a proof that the goal predicates with the help of your prior knowledge. So you want to construct a proof, just assume. So we taken an example 1 into 0 plus x, that is the example. For that example, based on some general rules, we constructed the proofs, tree structured proofs we constructed. How we constructed that proof? With the help of some background knowledge about that concept. What is the background knowledge we have? Based on that, we want to construct this proof. So first proofs are constructed. Why we constructing these proofs means to predict the goals. Okay, that is the first point. Then second point, in parallel construct a generalized proof tree for the variabilized goal using the same inference steps in the original proof. So when constructing the proof parallelly, you want to construct the proof tree also. So we already saw that diagram, tree structure. It's the same type of proof tree wants to construct. After constructed the proof tree, so construct a new rule whose left hand side consisting of leaves of the proof tree and whose right hand side is the variabilized goals. So after constructed the proof tree, you want to construct the new rules. So first you want to identify the example and construct the proof. Second one, parallelly you want to construct the proof tree. So after constructed the proof tree, you want to construct new rules. The left hand side for tree we have two sides, left hand side, right hand side. In the left hand side consisting of leaves of the proof tree and whose right hand side is the variabilized goal. So two things are there. Left hand side we have the leaves of the proof tree and right hand side we have the variabilized goal. And fourth, drop any condition from the left hand side that are true regardless of the values of the variables in the goal. So if you don't want any condition in the left hand side, we can drop it, but right hand side is contain the most important concept to form the rules. So these are the 4 points. So first we want to consider an example and construct the proof. That is the first one. Then second one, for parallelly for that proof we want to construct the proof tree. So after developing the proof tree, we want to construct the new rules. So here two sides, left hand side, right hand side. Left hand side contains the leaves of the proof tree and right hand side contains the variabilized goals. Then finally, if you want, if you drop any conditions from the left hand side, then the true regardless of the values of the variables in the goal. So unwanted results or values or anything in the left hand side we can leave, but in the right hand side the variabilized goals are present. With the help of that we want to find out the generalized rules. So that is the concept of or finding out the rules in explanation based learning. So in this manner we want to construct. That is the second one. The third one, improving efficiency. So after generalized rules are identified or constructed, how you improving the efficiency in that. So the choice of which rule to generate comes down to the question of efficiency. So which rule you want to generate? So that one comes under the concept of efficiency. Why? Because whatever the rule you are generated, it must be efficient. So there are three factors involved in the analysis of efficiency gained from explanation based rules. So what are the rules you are developed with the help of explanation based rule? So if it is efficient or not, to find out that one, we have three factors. One is one is adding large number of rules can slow down the reasoning process. So when you add large number of rules, it automatically slow down the reasoning process, because the inference mechanism must still check those rules even in case they are where they do real yield a solution. So when large number of rules, when large numbers are adding to the rules, whether the process is maintained in a proper manner or not, checking this one. So this is the first factor. In other words, it increases the branching factor in the search space. So if you given large numbers to the rules, it automatically increases the branching factors also. This is the first condition. The second one is to compensate the slowdown in reasoning. The derived rules must offer significant increase in speed for the cases that they do cover. So when you slow down the reasoning, so to compensate that one, we are providing speed for the cases. So for that, we can maintain the efficiency. That is the second one. So compensate speed, providing the speed. Then third one, these increases comes about mainly because the derived rules avoid dead ends that would otherwise be taken, but also because they shorten the proof itself. So when you increased it going on, it never gives the dead ends. So that's why. Then third one is derived rules should be as general as possible so that they apply to the largest possible set of cases. Then the final point is whatever the rules you are derived, it must be generalized as possible, as much as possible. Then only we can apply it for large set of cases. So these are those three factors. One, if you add large numbers, it slow downs. To compensate, second point, it's to compensate that slowdown. We are providing speed, high speed to the cases. So the third point is whatever the rules you are derived, it must be as general as possible. Then what is the operability? A common approach to ensuring that derived rules are efficient is to insist on the operability of each subgoal in the rule. So whatever the rules you are defined, if it is efficient, means it must be operable on each subgoal in the rules also. So on the subgoals also it wants to execute. The subgoal is operational if it is easy to solve. Whenever the subgoal is operationable, if it is easy to solve. So these are the points we need to remember in this concept. Generally, 3 points are there: constructing the general rules and constructing the general rules from examples, and improving efficiency and operability. So these are the points we need to remember in this concept. Thank you.